So we have to find a derivative of y is equal to x plus 1 of exponent x. Let's just rewrite this function first of all. Y is equal to x plus 1. Now remember, I want to tell you a very important rule. If you have something in the exponent, right, just like over here we have x in the exponent, so if you want to evaluate it or you want to simplify it and you want to find the derivative, or you have to apply any other operation on it, you can take log on both sides. So if you take log on both sides, it would be much more simpler to solve the question. So it is a general rule from now onwards, wherever we are going to get an exponent, we are going to use log on both sides. Okay, so I will simply apply the natural log on both sides of the equation. So applying natural log, so natural log of y is equal to natural log of x plus 1 x. Now there are some rules for solving logarithms. First of all, I told you this rule in my logarithm video, in which I said that if you have log function power m, we can actually separate this power and we could write m log x. So over here we have natural log x plus 1 x. So the natural log is actually the same thing as log, but if you're confused about it, you can watch my video on logarithm, finding the derivative of logarithmic functions. You would have much more clarification on these concepts. But for now, we are using natural log, and if we have natural log, the rules of log actually apply on it. So we can separate x and the natural log of x plus 1. Okay, so x over here was actually representing my m according to the general formula. Over here we have log of y, and now I can go ahead and apply the differentials on both sides of the equation. So d by dx log of y, d by dx log of x plus 1. Now a couple of things going on over here. Okay, so here are some important formulas and you can say theorems which are actually involved in solving this question. So the derivative of natural log of x is actually equal to 1 divided by x multiplied by the derivative of the same function present over here. So we can use this deduction on this thing right over here. So the derivative of natural log of y would be 1 divided by y multiplied by the derivative of the function. Now what was the function of log? It was y. So d by dx y. Okay, so these two functions are being multiplied. X is an algebraic function multiplied by natural log of x plus 1 is actually a logarithmic function. Okay, so those are two different types of functions, and when we have two different types of functions, we can use the product theorem. So the first function as it is derivative of the second function plus the second function as it is derivative of the first function. Over here this is my fx, the first function, and this thing right over here is my gx, the second function. So we can just go ahead and apply this formula. So the first function as it is derivative derivative of the second function plus the second function as it is derivative of the first function, i.e. x. Okay, 1 divided by y would be equal to d by dy by dx would be equal to, okay, so let's just simplify this thing, x. Now we know that the natural log, the derivative of log is actually 1 divided by x. Over here this thing is representing my x according to the original formula, so we can write 1 divided by x plus 1 because we are taking the derivative, of course, multiplied by the derivative of the function of log. Now what is the function of log? It is x plus 1. So d by dx x plus 1 plus natural log of x plus 1 is that it is, and the derivative will be cancelled and we are left with 1. X divided by x plus 1 multiplied by the derivative of x plus 1 is actually 1 because the derivative of x is 1 and the derivative of 1 is 0 plus the natural log of x plus 1. And now what do we want to find? We want to find the derivative. I even want to find the dy by dx. So we want this thing right over here, so I can separate this thing multiplied by y on both sides. We are left with dy by dx would be equal to x divided by x plus 1 plus natural log of x plus 1, and this entire thing is multiplied by y. Okay, so we actually moved y towards the opposite side of the equation by multiplying it on both sides of the equation. So when we move it to the opposite side, it will be multiplied by all of these terms present right over here. The actual value of y, okay, given to us was x plus 1 power x. So we can put this value right over here, x plus 1 power x, and then x divided by x plus 1, the same thing right over here, plus natural log of x plus 1. Okay, so this is the final derivative of this function.